Hey math enthusiasts! Welcome back to Maths with SAS, where we solve tricky math puzzles with logic and geometry. Today's challenge is, which of these shapes is truly half full? You might think it's just about filling half the height, but there's more to it. Let's explore this concept and solve it together. We're given 4 containers, each filled to a different percentage of height. But is height the only factor in determining whether they are half full by volume? To answer this, we need to understand how volume works in different shapes. The first instinct might be to say that half full means filling half the height. But for shapes like cones and other curved solids, volume doesn't increase linearly with height. For example, in a cylinder, half the height is indeed half the volume. But in a cone, half the height does not mean half the volume. Let's see why. The volume of a cone is given by V equals 1/3 of phi r squared h, where r is the radius of the cone and h is the height. Since volume depends on the square of the radius and the height, filling the cone up to half the height does not mean half the volume. Instead, we need to calculate what percentage of height corresponds to half the volume. Let's calculate the filled volume. In the same manner, we can calculate the volume of both the cones. Since the both tangent value is same for both the cones, we can say ratio of simple r by simple h equals to capital R by capital H. So we get the formula 3. Then let's divide the two volumes. We get volume percentage equals to capital R squared to capital H, divided by simple r squared to simple h. Then, by replacing both the capital R and simple r from equation 3, we get volume percentage equals to cubic value of ratios of heights. So we have this formula 4, says the volume ratios are equal to cubic ratios of heights. Based on this, we can calculate the height percentage versus volume percentage. So for a cone, you need to fill it to about 79% of its total height to reach half of its volume. For a cone, half volume happens at about 79% of the height. Looking at the choices, the correct answer is 80% or option C. Now, here's a new challenge for you. For a prism, how much height needs to be filled to reach half of its volume? We already know it's different from a cone, so what's the answer? Drop your answer in the comments below, and I'll pin the first correct response. If you enjoyed solving this puzzle, make sure to like, subscribe, and hit the notification bell so you don't miss another fun math challenge. Thanks for watching.